Okay, the next one then. We are looking at sort of, I suppose we're looking at the opposite of the chain rule really when we were differentiating. So in the previous video, we talked about how to integrate something such as sine of x, by knowing that minus cos of x would have done that. Okay. Will it let me write over here? No. Okay, cos of x plus c. So what about if there's sort of like a function within a function, or sort of a 3x, 2x? Let's have a look at this one here. So let's start over here. Imagine I wanted to integrate cos of 3x plus 1. Now, let's start with what we know is close, which is probably going to give you a good answer. So you know that cos will integrate into sine. Okay. So a good guess, let's call it a good guess. A good guess of what it might be is sine of 3x plus 1. So just change the thing to a sine, keep the bit in the mid in the brackets the same. It's not a bad idea. The only issue is if up here, if we differentiate what we think the answer is, because that's sort of like a way of checking your answer. But when you differentiate it, you have to deal with the chain rule. So you do get that cos a bracket bit, sure, but you also create a 3, and we don't want that. We get this, but we want it to go back and give us this answer here. So sine of 3x plus 1 plus c, this is sort of like 3 times too big, if you like. That answer is 3 times too big. We know that answer is 3 times too big because when we check it, when we differentiate, we get 3 cos blah, 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 instead of just cos blah, blah, blah. So what would you do? Think about what you're going to do in this situation. If this is 3 times too big, you can sort of ignore the c in your thinking. What do you do? Well, you scale it down. This is 3 times too big, so make it 3 times smaller. Divide it by 3, or another way of doing that is put a third at the front. The plus c is always a plus c, okay? Because it's just some number. So it doesn't make a difference if you divide it by 3. We still call it just some number. This now should be right. So let's check it. Okay, let's check this one here. So sine will become cos of the bracket. The c will disappear. We'll also have the third here, but then there's a chain inside, so times 3. So what you have is it cancels out, and you get back to the question, because the question was, how do we integrate cos of 3x plus 1? Well, that must be our answer then. Let's just go back to this one a little bit. So cos, sorry, this one here. So it gets a little bit complicated because you're checking your answer. You have to remind yourself of actually what you're doing. You're integrating cos. So the thing we want is this sine bit. Okay. Is there a shortcut? Yes. You've probably noticed that the x has a 3 in front of it. So I've sort of divided by 3. If we were going to integrate cos of 2x plus 1, that will be sine of 2x plus 1. But you will create a 2 from the chain rule, so you have to counteract that out. So you do a half. Yeah? This is what this section is all about. Okay? So how do you integrate this one here? Well, you integrate as you normally would, but then you have to cancel out, you have to compensate for this a. So you sort of put like a 1 over a at the front. Let's do a couple of examples. E to the 3x, what is a good guess? Use the standard results that you did in the lesson before. A good guess is e to the 3x. But when you test it, what you'll get is you'll get 3e to the 3x. It's 3 times bigger than what you want, so you have to scale down. So if you want this to be e to the 3x when you test it, if you divide by 3 on both sides, then it's saying what we should get is a third of e to the 3x with the plus c as well. It takes a little bit of practice to get. You can keep testing them the long way if you like to start with. Let's do another one. So think of this as sort of a little bit like 1 over x, 1 over thing. So what would 1 over thing integrate to? It would integrate to natural log with those lines there of thing. But when you differentiate this, you will get 5 over 5x plus 2. Okay, so what's the problem? That's a 5, that's a 1. It's 5 times too big. So if you divide it by 5 or multiply it by a fifth, then it works. So here is your answer. 1/5, so on and so on and so on. I'm going to reveal the questions here, and I want you to have a go. So try and sort of ignore the 3x minus 2 or the 3x plus 4 bit or the 1 minus 5x. Try and sort of ignore that part to start with. Think about what you would integrate it to normally. Check your answer, and your answer should not be right. You should need to scale it down or maybe even scale it up, okay, so that it fits, so that it's correct. So pause the video and spend at least 5 or 6 minutes having a go at those ones there. Okay, so I'm going to assume you've done that now. So keep the 2 at the front. Don't need to worry about that too much. Sec squared, so we're talking about tan. So we look at tan of 3x minus 2. The problem is it's 3 times bigger than it should be. So you need to divide by that 3. More complicated, this one, because the 2 sits at the front. The 2 and the third get put together, 2/3. Here, this is a bit like x to the power of 3. So bracket to the power of 3 becomes a quarter of bracket to the 4. But the answer is 3 times too big, so we'll have to divide by 3. A 12th. Sine, we know, goes to minus cos. Can we use the rule? Look at the coefficient of the x here and divide by that. So integrate minus cos of bracket, and to counteract it, minus a fifth. Okay, you'll have a double negative here. You'll have minus 1/5 times minus cos. That's why you have a positive answer. This one here, okay, we're going to get a 12th, or sorry, minus a 12th. The same kind of thing happening again. A bit trickier, that one. Bracket to the 12 is bracket to the 13. Okay, you'd have to divide by 13 anyway, and you have to counteract the 10. So if I just discard here, this is all summed up. This is all summed up by this black box here. So if we have this thing here, look, the f dash is the derivative. So you have the antiderivative. In other words, you integrate the thing with the input the same. So any brackets or inputs for sine and stuff is all the same, with your plus c as well. And then to undo the fact that x is 2x, 3x, 5x, you divide by that. That's what's going on. That's what that rule means. A couple more here. So best guess is this should be e to the 3x plus 1. Why is that our best guess? Because e to the x, e to the thing differentiates to e to the thing if you differentiate by that. The 3x will make it 3 times bigger, so you counteract it. Okay, this one here, start by thinking that this is a little bit like 1 over x. So we want natural log of 1 minus 2x, and then we need to balance out the fact that there's not a 2, but a minus 2. So it would be minus a half, again, plus a c, okay, plus a c. I'm just going to sort of reveal these ones and we'll just talk through it. So bracket 5 becomes bracket 6. You'd have to divide, so you would have 1/6 anyway, because you divide by the new power. That's normal integration. But then you also have to have one of those as well. That's where the minus 1 over 18 is coming from. And this is sectan. Sectan is sec of the same bracket. There's creating an extra 3, so you need to cancel out that extra 3 and plus the c, of course. Okay, so this exercise here you will find quite fairly challenging. I would recommend, even if you've heard what I've alluded to already about substitution coming on later, it's still a good one to be able to do quite quickly, especially with the more simple examples like this one here at the top. Okay, you might save yourself a bit of time by not needing to do the substitution. So you should be ready to have a go at these questions here from the book. And that's where we're going to leave that video.